Let's talk all about AI in business. It's hosted by Brent Muller. Welcome to the Future Proof Podcast.
Hi, and welcome to the latest episode of the Future Proof Podcast. I'm your host, Brent Muller. I'm joined today by Shay Harrison, the CEO at Freeform Fibers. Hey, Shay, how are you?
Good. How are you doing today, Brent?
Excellent, excellent. So as we always start with on our podcast is let's talk about your background. Talk to us about your journey leading up to this position.
Yeah, it's, I would say, a nonlinear process that got me to this.
It usually is, by the way.
My background is material science. I did an undergraduate BS in material science and engineering at Rice University. Started out at University of Texas at Austin, and my advisor left after a year. And I went with him up to University of Connecticut. And the technology that we were working on is this thing called laser-driven chemical vapor deposition, or LCVD, which is, very interesting, but also can kind of glaze your eyes over if you haven't seen it in operation. I graduated with my PhD in 1999, and the technology was not ready for prime time. It needed some improvements in terms of the controls, in terms of the lasers. And so I went off to work in industrial R&D in materials for about 13 years. In the meantime, a couple of folks that I knew in this space, and it's a small community. There might be 25 people in the world that have expertise in LCVD. And we have 5 of them here now at Freeform Fibers. So we've cornered the market.
Yeah, you've cornered the market for sure.
Right. And so these three guys started the company in 2006 and made some pretty important technical advancements in terms of making the technology scalable. And they actually ended up locating the company in Saratoga Springs, which is a little bit north of Albany, New York. And I'm from Albany.
Okay.
I lived in Albany, mostly grew up in Albany, and had moved back and was working at a company running their R&D department, and got connected with these guys. I couldn't believe they had started a commercial entity that was, making a run at turning LCVD
in your home backyard too.
Yeah, in my backyard,
Crazy.
right? I mean, just better to be lucky and a little bit random than good, in that case.
Yeah.
And so I joined as the material scientist in 2012. And this is a materials manufacturing focused company working on challenging materials. These are things that we work on are really for really tough applications in nuclear energy, aerospace, defense, high speed vehicles, missiles, things like that. And so it took us a while. It's a hardware, not a software play in terms of what had to be developed.
Wow.
And our former CEO had been a successful entrepreneur previously, had a payout, and he and his wife were ready to enjoy some of the fruits of that. So he was ready. And so he stepped down in 2020, September of 2020. And I surprisingly took over. I didn't at first believe him when he said, "Hey, you should think about being the CEO because I'm thinking about retiring." And I kind of laughed it off like, me? So I took over in September 2020, and we were fortunate enough to have some private investment that came in that allowed us to kickstart our commercialization. We really had a strong reputation in the field that we're in. It's called CMCs, ceramic matrix composites. That's where our materials are used.
Okay.
Strong reputation in that community, but as an R&D company, not as a manufacturer. And so we decided it's time to commercialize. It's time to take this thing out of the lab and make a go at trying to make, volume scale production using the technology. And so that's what we've been focused on for the last 4.5 years. And, today we are, we're selling product, not in the little thimbleful, but actual, by weight kilograms to customers as they are evaluating the things that the products that we make in their manufacturing processes. So we are a company that is getting our legs as a real manufacturer.
So you figured out what you want to be when you grow up, and now you're growing up. That's fantastic.
That's it. I'd say we're trying to become a big boy company.
Yes, exactly. So just for the viewers out there and listeners, give us a couple of examples of the type of products that you're now selling.
Sure. So we, the name is a good indicator, Freeform Fibers. So the way that composites work, particularly ceramic based composites, are that you need to add the fibers to allow it to behave in a manner that's like metals. CMCs are used to replace metals for a couple reasons. One, they can go to higher temperature. Two, they are lighter weight.
Be important for a missile, right?
Anything that's flying, right? NASA,
Yeah.
DoD, aviation,
Aviation, right?
right?
Yeah.
And so, and in nuclear power, there's a more of a safety factor involvement for these materials. But again, it's because it can go
Makes
to higher
sense.
temperature. And so in order to make that, so if you think about it, the example I always give, if you think about a dinner plate, ceramic dinner plate that, you have at home, you drop that on the floor, what's it going to do? Shatter into 1,000 pieces. You need it
Right.
to act more like the metal dog bowl that give your dog their food in.
Right. It just rattles around, right?
Just rattles around, takes a little dent, and you can use it again. And so you don't want that material that's based on the dinner plate in a engine flying on a commercial airline,
Yeah.
right? And so
Yes, that would be scary.
that's not what you want. And so the materials that we make, the fibers that we make, go into those composites that make components that are in aviation engines flying right now. Now we aren't in those engines. That the example that has really the company that has really pulled along CMCs is General Electric with their LEAP engine. And
Okay.
if you fly Delta or Southwest, that engine on those planes has about 5 weight% of these composites, these ceramic matrix composites on them. And so we're working towards getting our materials into applications like that with customers in the defense prime space, in aviation, with nuclear energy partners, applications like that, partners like that.
Wow. That's amazing. That's amazing. And so you kind of outlined your vision, but anything more about how where you see this going, right?
Yeah, it's so these materials. So to put it in perspective, people started working on CMCs in the 60s and 70s, right? It takes a while. The first,
Right. Long evolution here.
right? It's a technology evolution. Again, another example I use is the Dreamliner 787 is 75% carbon fiber based polymer composite. So they've replaced the aluminum fuselage with these carbon fiber materials, and that's not what we're not in that space, but it's a good example.
It is a great example. Yeah.
Carbon fiber composites were developed for NASA in 1960, and the Dreamliner came out in 2008, 2009. Right, we're at the beginning.
So it's fast adoption.
Right, it took a while, and so the things
Yeah.
that we work on are certainly where they were 15 years ago. It has curve is exponentially increasing, and so our vision is to be, as these companies and these different manufacturers in these fields are adopting CMCs into their standard products that they're making, we want to we want to go along with that growth. And so, our focus is, improving our manufacturing process so that we, as we scale up, we can meet that demand for 100
And
kilograms.
be a player in that space, right?
Right.
Yeah.
Exactly. So it's a
No,
growing area.
unbelievable. Yeah. So tell me about, so this is what, year 5 of you being the CEO? Yeah. Tell me about your biggest maturation and basically learnings over the last 5 years.
Yeah, I've coached basketball. I've done other kind of leadership things. No matter what you do, unless you're kind of coding a program on your computer, you got to deal with people, right? So
Amen.
right, that to me that wasn't the challenge, because at least, or as challenging, because at least I had done things where you had to,
Had to do that, right? Yeah.
right.
People wasn't your problem. Okay, good.
People wasn't the problem. It is the challenge is we are in, as I mentioned before, right? We're materials, we're in manufacturing, we're in aviation and defense, keeping this thing afloat, keeping it going. And I will say we've been fortunate that we make use of programs called SBIRs, Small Business Innovative Research, grants and projects through federal agencies, and particularly Department of Energy and Department of Defense. And we've been very successful in being awarded grants like that and navigating that path of getting investment in, going after the right grant programs. How do we kind of mesh all this together to build our way through the valley of death? Because I mean, truly, we are in the middle of that, trying to scale up, and we're past the point of proof of concept. We run our production tools 24/7, right? So it's not a case of can we do this? We know we can, but now we need to make sure this thing can grow and survive to the point where we're revenue sustainable.
Yeah, totally get it. Totally get it. So as you look down the next 1 to 2 years, well, what's the crystal ball look like? What do you see in the industry? What do you see changing, and what can you take advantage of?
Yeah, the adoption of these materials is definitely broadening. And I will say one of the advantages of our technology is that there's one material in particular that we have. There's a competitor, Japanese competitor, that's been around for 40 years making this material. We can
Okay.
make a similar material that's better in properties and therefore performance. So in that space, we're trying to gain our leverage in there by showing use our material and you'll get a higher temperature capability. There are other materials that people have been trying to make in fiber format for these composites for 50 years, and they haven't been able to. We actually have two products, one that we've been commercially selling since last year and are seeing, again, kind of a ramp up of interest. And then another just recently that we've shown, again, that people have been trying to make for many years that nobody's been able to. And so with those products, we're trying to get that out to users so that they can actually turn the before it was concept, hey, we'd love to have this type of fiber material but nobody can make it, so it's still an idea. Now it's a reality, and so we're over the next 12 to 18 months we're trying to push that dual different states of market adoption and awareness, but getting people to try our material, to know that, hey, when you want to if you want a silicon nitride fiber, there's only one place in the world you can go to, and that's freeform fiber. So it's really
That's a cool place to be. Yeah.
yeah. I'm very grateful that they're not trying to be me too, right?
Yeah.
There's unique products and offerings that we can deliver to the market that's only us, only through our technology.
That's really, really, really special. I hope that is a revenue stream for you guys, and basically a lighthouse of being the only one. That's very, 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 very cool place to be. Talk to me, Shay, about how you see the industry, because every industry is being impacted by emerging technology, data, AI, robotic process automation. Any automation in general. How is your business impacted, and then how's the industry?
I mean, automation, efficiency, and production. These are crucial for the adoption of these composite materials because they're very expensive, right? I'll call them niche markets where they will pay for the higher performance in order to get the adoption down to heavy industry. My previous job at the company I worked at before I came here, you sold ceramic products to oil and natural gas refineries and industrial process and heating. So I'll call them heavy duty, dirty factories, not dirty, but
Right. Right.
down and dirty kind of thing. And these composites that we work on in these fields, it's way too expensive, right, to be adopted there. And in order to get these materials, the price points, the cost of these the manufacturing of these composite materials down to the point where it can more get broadly used, automation, efficiencies in talking about data analytics, right? You've got to use an informed approach to manufacturing because you can't kind of like put your thumb up and guess, well, if I my processing temperature here by 100 degrees, that'll make this impact. No, you need to collect that data and then go evaluate it and make the smart decision. And I think that's where, in the manufacturing industry for these types of high value materials, automation, data analytics, we're actually going to have an intern next week. I went to Rice and they have an externship program for undergrads. And I didn't think anybody would want to come to upstate New York from Houston in March, but this student did, and he's very interested in data analytics, and gonna show him what we're doing now and where we need to continue pushing through. And he said that there's a number of students in his cohort that are focused on that engineering, data analytics, AI use of inputs to drive learned outputs kind of thing.
Fantastic. I love it. I love it. And honestly, that's how you drive faster insights to make better decisions. And if that feeds up to you and your decision making team, that's phenomenal.
Yeah, absolutely.
Yeah.
That's what's needed.
So tell me, I mean, do you have any, tell me one of your cool customer stories. You have to have some really cool stuff that you've done because that no one on the podcast, they're probably, I'm thinking it now. So a bunch of people are probably thinking, all right, Shay, tell us like, give me some cool applications.
So in the nuclear space, the driver for these kinds of composites came out of the Fukushima accident in Japan. And
Wow.
really what happened at Fukushima was the circulating water, the pumps for the circulating water to cool the fuel rod,
The reactor? Right.
right? The pumps went out because, strangely enough, at a power plant, they still needed a nuclear power plant still needs electrical backup to drive to drive the pumps. And so what
Yeah.
was when those pumps stopped circulating, the water started heating up, and the material that's been historically used for these fuel rods is a metal, and that water, that high temperature water and metal started reacting and basically broke the water apart, created hydrogen gas, built up pressure at the top of the stack, and eventually the pressure blew the top off. And
Wow.
the whole point of using composites, and this is actually driven by Congress in 2012. They set up a program, a 10-year program, which is now extending out to longer than that, 15 years really, to develop materials that would prevent that type of accident here in the United States. And that's where the fibers that we can make go into these composites. These composites get deployed as a new material. Instead of having that metal interface with the water, now you have an interface with the composites, and you avoid that. The composites, the measuring stick is LOCA, loss of cooling accident. How long do you have in a LOCA situation? And so at Fukushima,
Interesting.
it took about I think 36 hours for enough of that hydrogen gas to build up to blow off the top. So
Yeah.
the goal of using these composites is to take that 36 hours and make it a week, so that, again, you're just trying to buy enough time so you can
Right. To get fixed. Right.
Exactly. Exactly. So that's something that we've been involved in for probably 7 or 8 years, working with different partners in the nuclear energy space, developing our materials, developing some technologies that we've created here to support that application of composites into fuel rods.
Wow, that's amazing, and that's a very good story that people can actually see the immediate impact, right? Yeah, and so you start to extrapolate that out, and you can see all kinds of other areas where you can. It's not just disaster prevention, right? But it's there's all kinds of benefits you can start to see from composites.
Absolutely. Back to that airplane engine application, both commercial and military, right? But from a commercial standpoint, what GE did with the LEAP engine, they improved the temperature capability of from the superalloy metal, which was about, call it 2,200 degrees Fahrenheit. They improved that
Hmm.
temperature capability up to about 2,350 degrees Fahrenheit. So that 150 degrees, the joke that, I'm not an aerospace engineer, right? I'm a materials, right?
Right, right.
But what I have been told at conferences and meetings is that, an aviation engineer designing engine components will kill his grandmother for an extra 1 basis point of fuel efficiency, right? And so you can, you can
Yeah.
with 150 degrees, you can drive improved fuel efficiency. And in addition to that, that higher temperature capability, like I mentioned, the composites are lighter weight. And so therefore,
I was just going to ask how the weight difference is. Yeah.
exactly. So you can nominally call it, 2 to X in terms of the reduction in weight between and actually it's probably more like 4 to 5, but conservatively, you're getting multiple X reduction in the specific density of the composites compared to the metals. And so again, as you start to increase the number of components that are made out of composites, you're going to drive out hundreds of pounds of weight on the engine. And therefore, the way that it's been described to us, you're either going to be able to fly longer, right, on that tank of fuel that they fill it up on, or you're going to be able to go faster, right, because you can.
Right. Get there quicker.
Yep, exactly.
Yeah. Which is what everyone would rather have, right? I mean, listen, yeah, you can get there quicker.
About
It's
the
great.
longer is UPS and FedEx, right?
Yeah, exactly. I love it. I love it. All right. I told you I was going to ask you a couple questions at the end. First is, Tell me something, Shay, the CEO, has done or uses AI to make yourself more productive.
I will say, it's definitely over the last 3 or 4 months, 4 or 5 months, that it is a great tool to compress information that you're getting in, right? I'll get a summary of an article or a summary of an email, and I can decide, am I spending another 5 minutes reading that article? Is there something in there that's of
Right.
interest? Or,
Right.
hey, you know what? Let me flag that. I'll come back to it. Similarly with emails, I probably get 75 of a day, which is probably not as many as a lot of executives get, but they can be very pointed with some of our partners at the government.
Imagine.
Right. And so, trying to prioritize that. And again, getting that quick summary of, is this just hey, thanks for letting me know about, some information that we passed along, or is there a real question that I need to follow up on? Just from a personal productivity standpoint, it has allowed me to move quicker and hopefully accomplish a bit more in my day, just because I can kind of jump from one thing to the next and not necessarily fight the fires that pop up, but be able to address things at the right end order.
Yeah. So when you go through your 75 emails, do you use a certain tool, or are you just using something like Copilot, or what do you use specifically?
Yeah, I think it's Copilot. Yeah, that gives me that summary. We outsource our IT services. We're 12 people
Yep.
as a company, right? And so
Right.
there's certain things that we use external providers for. And so I'll be honest, I think it's Copilot that they installed to the
Yep. Yeah.
email system.
That makes sense. Yeah, absolutely. Yep. Yep.
But very helpful.
No, Shay, that's awesome. It's very helpful because honestly, to me, the more efficient that we can be at the management level, especially the C level, the more crucial things get focused on. And that's always been a deterrent between meeting schedules and just email follow-ups and all this kind of stuff. If you can figure out how to streamline that, which you just talked about, a really nice way to do that, it's very, very helpful.
It builds on
Okay.
it actually
So
builds
last,
on one of the
yeah,
things
go ahead.
you were asking about. Well, what is some of the important lessons that I learned transitioning into the CEO role is that prioritization. I'll be, that took me a little while to understand. But as an engineer, as a technical person, you can get bogged down on certain things that aren't the priority. But that was definitely a
Yeah.
lesson that I learned of, trying to figure out, okay, here's what to pay attention to now, and here's what to, come back to. So that was an important lesson, and this has helped, right? In terms of that
Yeah.
process.
Absolutely, absolutely, and we'll send you some cool prompts to test out as well. They're coming out. The last question I have for you: growth goals, right? You want to hit your next 12-month growth goals. Certainly top of mind for every founder and CEO. If I give you a magic wand, what would you use to help enable that?
So that, this is talking about AI, and we've been talking to a couple folks that are focused in manufacturing, have experience in manufacturing, about how to utilize AI. And the thing that we have, I don't want to say we've been slow, we've been considerate about. We don't have a decade's worth of production data, right? We have, as we've expanded it and increased the number of production tools that we have a certain size data set, and we've been concerned, is that big enough to feed into an analytical
An
tool?
LLM, right?
Right, exactly.
Yeah.
And so, well, I think when we get bigger, so I would hope, in 18 to 24 months, when I actually need more help in kind of the logistics planning and getting, our raw materials are gases. That's the only raw material we have, but getting delivery schedules and mapping out, when we need them and automating that with our, suppliers. That's something that, as we grow as a manufacturer, that's where I see AI having an impact. But in the kind of that 12-month time frame, as we want to improve our production efficiency, that's where we're trying to figure out how we can implement, AI tools with an LLM, where, hey, these are our production rates, and here were the parameters that went into those, the data that is being generated as we produce material, and how can that spit something out that helps us directionally, back to efficiency, right?
I'm glad you're thinking about that, because to me, everybody I talk to in manufacturing, that should be their number one thing is, how do I maximize that production efficiency? And that's where AI can really make a difference. It really, you just think about it, it's a crazy fast number cruncher,
Mhm.
right? To produce right? And it's not always 100%. The nice part is if it can get you 80% of the way there, your team can then be off and running very fast.
Right. Absolutely. Yeah. I mean,
Yeah.
it's a tool and use it wisely, right?
Absolutely. Thank you for spending the time today with us. It's been great. And I've learned about new composite materials I did not know about. And I think there's a lot in the audience that didn't. So that's fantastic.
I appreciate the opportunity, Brent, very much. It's been great to talk with you.
Yeah. Well, thank you for spending the time. And for this episode of the Future Proof Podcast, I'm Brent Muller with Shay Harrison. And this is where leaders and technology come together to drive business growth. Thank you.
If you're ready to embrace change and lead with innovation, be sure to subscribe and never miss an episode. Thanks for tuning in to the Future Proof Podcast.